The objective of the following animation is to give a schematic representation of the mechanism to be used for obtaining variable valve timing in the inlet valves of the engine. Here we can see the camshaft with the two cam lobes having different cam profiles to be used for the same valve, and the rocker arm shaft above it. A specially designed ring, with notches machined on it as shown, is brazed onto the rocker. A compression spring is then placed between this ring and another ring with teeth corresponding to the notches of the previous ring machined onto it. This second ring is brazed onto the other rocker arm, and this entire unit is placed on the rocker arm shaft. The fork-like arrangement shown is used for sliding one of the rocker arms. The red rocker arm presses against the valve and controls its opening and closing, while the blue rocker arm is redundant at lower speeds and just presses against a spring, without transferring any motion from its corresponding cam to the inlet valve. Here it is important to note that the two rings brazed to each shaft are separated from each other by the spring force. The green cam has a wider profile than the black cam, and it keeps the inlet valve open for a longer duration. Here we can see that the motion of the two rockers is not synchronized, as the cams operating them have different profiles and there is no rigid connection between these rockers. When the engine speed increases above 3000 RPMs, in order to obtain better volumetric efficiency, it is necessary to increase the duration for which the inlet valve is open. When the required RPM is reached, the fork pushes the blue rocker arm, which slides on the shaft, and thus the two rings engage and provide rigidity to the oscillating rockers. Now the two rockers move as one, hence the wider green cam now becomes the dominant cam, and it causes the red rocker to get lifted off its black cam when the wider portion of the green cam comes into play. Thus the valve opening is now controlled by the green cam, which has a different profile, increasing the duration of the valve opening and allowing the required amount of air to enter at higher speeds. Thus it helps in maintaining the volumetric efficiency.